Howdy, this is JR with Firmatech Seismic. I want to thank you for joining us on our blog. Glad you're here at our website. Over the years, we have monitored thousands of shots for several different companies, and we've talked to a lot of homeowners who are concerned about the impact of that blasting on their homes. We've sat in their homes while the blasts went off, we've sat outside their homes when the blasts went off, and we've heard them describe to us in several different ways what it is that they're feeling. So I thought that after years of doing this and after drawing a lot of pictures for a lot of people, it might be helpful to create a blog post which just illustrates a couple of the different things that they may be feeling and where they come from. So we're just going to start with a simple diagram right here. Here is a home. Over here we've got a nice sunny day, and then here is a pit. A rock quarry that's active. Now that pit is going to be extracting the rock from the ground more than likely using explosives. And so let's just make an assumption here that we're using explosives. And what I've got here is a couple of explosive columns that were created by a drill coming in, drilling holes along the active face, and then those holes are then filled with some sort of powder or some sort of a blend that, when detonated, produces energy. Now that energy mostly goes into cracking the rock. That's what it's supposed to do. The rock simply moves forward, and really good blasts are pretty non-dramatic. They don't have stuff flying all up in the air like we used to see on episodes of Little House on the Prairie and stuff like that. The rock just kind of falls down to the ground when it's done well, because most of the energy from that blast goes into cracking the rock. However, some of the energy is always going to escape, and it's going to escape in one of two ways. One is going to come in the form of air overpressure, or what we would typically call noise. The other one is through ground vibration. So when these two explosive columns go off, they're detonated, what we're going to see is the release of energy. Most of the energy is in the form of rock that gathers right in this area. Some of the energy escapes that blast in the form of ground vibration. In this illustration here, we've got ground vibration that's traveling through the rock. It does not travel through the air. It must travel through the rock. And when you're really close to the blast, that intensity is going to be very high. But very quickly, the ground vibration, or the intensity of the ground vibration, dissipates into something much less. And so what you'll find is, very close to the shot, you've got high intensity. Once you get a little further away from it, you're now safe. You may be able to feel it, but it's not anything that could do damage to your home. And then eventually, once you get further away, while the ground vibration may be annoying, the ability for that ground vibration, or the potential for that ground vibration to do damage to a structure, is very little. So here we've got ground vibration going in this direction, and it's always going through the rock. Now, there's a second way that energy escapes, and that is through what's called air overpressure. Let's move over to the other side of the pit here. For illustration purposes, we've got our explosive columns right here, but now the ground vibration, while it's going back in this direction, it has another escaping form of energy that goes in the opposite direction. Air overpressure is going to come wherever the rock has been fractured. So since the rock fractures on the front side of the face, it's going to come straight out this way. It's also going to come up in this direction. And since the rock on top of the explosive column is going to be cracking, it's also going to go up. So you can tell that a home far off in the distance is more likely to feel air overpressure than it is ground vibration if this is the side of the pit that's being blasted. If, however, this is the side of the pit being blasted, the same side as the home, more than likely it's going to be the ground vibration being felt, not the air overpressure. Now here's another unique thing about about air overpressure is that it's not near as predictable as ground vibration. This ground vibration, as it travels through the ground, has got a medium that's pretty consistent. So if I were to know the distance between the source of the blast and I was to know exactly how much energy was being produced in that explosive column, I could pretty accurately predict what the reading was going to be at a certain distance. For example, if there's a monitor in this yard right here, I know exactly how much explosive is being shot, and I know the distance from the explosive column to the home. I can, with pretty decent accuracy, tell you what's going to be there, and I could blast it over and over again, and my results would be almost exactly the same. Not true with air overpressure, unfortunately, because the atmosphere provides a whole bunch of different variables that may make two blasts that are of similar intensity feel very different on two different days. This illustration right here on a cloudy day would show that the clouds can actually produce kind of a reflective surface, so that this could be a point where the explosive energy, or not the explosive energy, but the air overpressure is more focused. On a different day, without these clouds here, sometimes the air overpressure just goes up and it doesn't reflect off of anything, and so people who are close by or far away don't tend to feel much of anything. Now sometimes there's also what can be called a thermocline, or some sort of a thermal layer that exists here, where there's a temperature difference, and the air overpressure will bounce off of this, and it will reflect off of it and find some point that's further away than normal that's going to feel that intensity more. So if the wind is blowing in this direction, then the people downwind are going to be able to feel it, while it kind of protects the people who are upwind from feeling it as much. So chances are, if you do live near a rock quarry, you're feeling one of these two different effects. It's either ground vibration or you're feeling air overpressure. I hope this helps explain with some clarity what it is that you may be feeling. You can always feel free to give us a call, or you can write some comments on the blog post beneath, and we'll do our best to answer your questions. So we want to thank you for visiting our blog, and hope to have you back here again soon. Thanks.